Hello and welcome to this video on vectors for FP4. Now, instead of doing what I normally do and teach you everything about everything, I'm going to go through a question with vectors because I feel this is the best way to learn most of the techniques that you'll probably need to answer a question. Now, the question I've picked is the question 8 from the June 2016 paper, so if you don't have that in front of you, it might be advised to get it in front of you and have a look. I will write bits of it out, but the chances are you're better off actually having it in front of you in order to see. So we'll start at the beginning and we'll see what happens. Now, the first part says that the plane pi 1 is perpendicular to the line r minus 2, 4 minus 3 times 5, 2 minus 1 equals 0, 0, 0. Hopefully that is perfectly legible. Now, some of you, the more observant, will have noticed that this is in the form r minus a times b equals 0. Now this is going to be quite helpful for this question. Now that we've got the equation of the plane, we can work out the rest of the question. The point 3 minus 1, 2 lies on the plane pi 1. Find the equation for pi 1 in the form r dot n equals c. Now, they've helped us quite a lot with this question in the fact that they've actually given us the perpendicular vector, because they've said that they want it in the form r dot n equals c. Now n, for those of you who don't know, is the perpendicular vector, and the perpendicular vector in this case is 5, 2, minus 1. So the rest of it is fairly straightforward. R dot n is equivalent to a dot n, as c is equivalent to the dot product of the perpendicular vector and the point 3 minus 1, 2. So all we have to do is write r dot 2, 4 minus 3, as that is our perpendicular vector slash direction vector, equals 3 minus 1, 2, dot product with 5, sorry, that should be 5, 2 minus 1. My fault for not reading the question properly. 5, 2 minus 1. Now, if we do the dot product, then we times the x by the x, the y by the y, and the z by the z, add them all together. So that will be 15 minus 2 minus 2, which is 11. Therefore, our finished form of the equation is r dot 5, 2 minus 1 equals 11. For 2 marks, your first mark will be for probably putting it in the form r dot n equals a dot n, and then your second mark will be for getting the right answer. Now we can move on to part B. Now part B says the plane pi 2 contains the point 2, 3, 2, 4, 1, minus 1 and 0, minus 1, 2. Show that an equation for pi 2 is 2x minus y plus 2z equals d, where d is an integer to be found. Now then, the first thing we should do is really write down all the points as actually assign a letter to each point. So A in this case can be 2, 3, 2. B can be 4, 1, minus 1. And C can be 0, minus 1, 2. So the first thing we need to do is we need to find the equation of the plane in the form r equals a plus tb plus sc, which I will write here, r equals a plus tb plus sc. And for those of you who've got the formula booklet in front of you, you will know that the vector b is equivalent to b minus a, and the vector c is equivalent to c minus a. So to find ab, which is b minus a, we do 4, 1, minus 1, minus 2, 3, 2, which gives us the vector 2, minus 2, minus 3. Then we do AC, which is C minus A, which is 0, minus 1, 2, minus 2, 3, 2. Equals minus 2, 4, 0. Sorry, minus 4, 0. Now then, now that we've got AB and AC, we know what the equation of the plane will look like. But we need to actually find the perpendicular vector, because they want it in the form r plus n equals d. Now, if we times b and c together, then we are going to get the perpendicular vector. To illustrate this, I'm going to draw a plane. Draw a plane. Now, you will need a vector to get onto the plane, and then using a combination of vectors b and vectors c, you can get anywhere on the plane that you want to go. So, therefore, in order to find the perpendicular vectors of those two, we need to use the vector product, or the vector product, cross product, whatever you want to call it. So in order to do this, what we do is we just take 2, 2, minus 3, and multiply it by minus 2, minus 4, 0. Now there are a couple of different methods of doing this. The one I tend to use is if we do the determinant of the two rows below the one where you want to do it. So in this case we want to find it of the top row, we do 2 times 0 minus 3 times minus 4, which is minus 12. Then we move down. We can write the top row under the bottom row again, like this, so. Hopefully that is perfectly clear. And then we can do the determinant again, in which case it is just 6. And then finally we must do the last part, which will be minus 8 minus 4, which will be minus 12. So there, now we have vector n. Vector n is minus 12, 6, minus 12. Now then, the more eagle-eyed of you would have noticed something. They want pi 2 in the form 2x minus y plus 2z. Now, if I was to take a factor of minus 6 out of that bracket, then what would I get? 2 minus 1, 2. Now, to write that in vector form would be, or write that in as the equation in plane would be 2x minus y plus 2z. So there we have it. We've now found the vector. Now all that's left, if you'll excuse my drawing arrows everywhere, is to find the actual integer d. So in the same process as we did with part A, in terms of we got the value of n and dotted it with the value of a, we're going to do exactly the same thing. Now you will remember from earlier in the question that we used we assigned 2, 3, 2 to a. So that's what we're going to do here. We're going to do the dot product of 2 minus 1, 2 dotted with 2, 3, 2. And this will give us 4 minus 3 plus 4 equals 5. So our final answer is going to be 2x minus y plus 2z equals 5. And there you have it, 5 marks. First mark will probably be for actually assigning values to your vectors and finding the direction vectors a, b and ac. Then another mark for your parallel, for actually doing the vector products, working out it's a multiple, and then obviously doing the cross product and actually writing the correct answer. Now then, we're going to move on to part C. Paper over. Now then, part C is all about finding angles. Now we know that the equation of pi 1 is 5x plus 2y minus z equal 1, and pi 2 is 2x minus y plus 2z. Now if we write this in column vectors, then it will be 5, 2 minus 1 and 2 minus 1, 2. Straightforward enough. Now then, some of you may remember this formula from either Core 4 or just from the earlier chapters in the FP4 textbook. A dot B equals magnitude A, magnitude B, cos theta. So, it would stand to reason that if you want to find cos theta, then you can do cos theta equals A dot B over magnitude A, magnitude B. Now that is exactly what we're going to do here. We're going to do the dot product, which is 5, 2 minus 1, dotted with 2 minus 1, 2, over the magnitude of vector A, 5 squared plus 2 squared plus 1 squared, times 2 squared plus 1 squared plus 2 squared. And this will give us, obviously once we've dot product, it will be 10 minus 2 minus 2, which will be 6, over root 30 times 3, so 3 root 30. Now, if you put this in a calculator, it will automatically find your values in the simplest form, which will give you cos theta equals root 30 over 15, which is the form the question wants you to find it in. So there you have it. That's a couple of easy marks as well. Now then, you don't actually need to show the acute angle, it just asks you to prove that's what it is. Now, part D. Part D does look very complicated, but it's actually relatively straightforward. If you were to write the equations of all the planes in a matrix, so we had 5, 2, minus 1 for 5x plus 2y minus z. Then for the next one we did 2, minus 1, 2. And then we have obviously the values from the question. So we can write 4k minus 8 as it's 4 lots of k plus 2, or sorry, 4 lots of k minus 2, k plus 1, and minus 4k squared. Now then, if you have it in a form like that, what do you think they're going to ask you to do? Now, my guess would be find the determinant, and that's exactly what we're going to do in this question. Now, for those of you who can't probably read that, I'll write it a little bigger so you can read it. There you go. Now, to find the determinant of this, we effectively do the 2 by 2 determinants and times it by the value on the top row. So what we do is we do 5 lots of minus 1, 2, k plus 1, minus 4k squared, minus 2 lots of 2, 2, 4k minus 8, minus 4k squared, minus 2, minus 1, 4k minus 8, k plus 1. Now, I'm not going to insult your intelligence by expanding all the determinants out, but I will tell you what the answer should give you, and then hopefully you've got something to refer to, so if you get it wrong, you can always try again. You should get, after simplifying everything down, 36k squared minus 36 equals 0. Remember to always make the determinant equal to 0 if you're doing something like this. Now, obviously, what you can do is write 36k squared equals 36, therefore k squared equals 1, and therefore k is plus or minus 1. Now, if you look in the question, it will say, show that one possible value of k is 1, and find the other possible value. And therefore, what your other possible value is minus 1. Now, usually if you've got a squared term, you've got to remember that there is a positive and there is a negative. So now, let's do the final part of the question, which is literally substituting your values of k into the equation of the plane and then working out what you've got. So, when k equals 1, we do minus 4x, this is having substituted k in, plus 2y minus 4z equals to 8. Now, if you've noticed something about this, similar to what we had in part B, if you were to take a factor of minus 2 out of that, then you'd end up with 2x minus y plus 2z. And what does that remind you of? The equation of plane 2. So therefore, we can say that when k equals 1, pi 1 is parallel. And then finally, when k equals minus 1, then we get minus 12x minus 4z equals 8. Now, this is a bit different. If you notice that that does not look anything like the other planes, so you can simply say, since planes have no common point, since planes have no common point, 3 planes form a prism. Now then, that is the worked answers to every question every part of that question. Now this question is quite a good one to do if you want to revise FP4 for a number of reasons. It uses R minus A times B, which is a form that you don't often use in questions. You need to use the equations of planes, you need to manipulate them, you need to use your stuff for angles, you also need to be able to sort out matrices, and you need to work out what geometrical configurations are. So the chances are, if you can do this kind of question, you can pretty much do any type of vector question going. So I'll bid you adieu for now, and I hope this is useful. Please like and subscribe.